Hi, we are going to cover the concept of permutations and combinations in today's session. Permutations and combination concepts are important in the theory of probability and ways to select how many ways we can choose things from certain collection of objects. Say in our example today we have four numbers that we are trying to select here. 1, 2, 3, 4, four numbers. And if I'm asked the question, how many ways I can select two numbers out of these four numbers, what's the answer? So if I start arranging, like if I want to select two numbers and I can start putting them like this. Suppose my first number could be either 1, it could be 2, it could be 3, or it could be 4. So I can select any of these four numbers in four different ways. Similarly, the second number, if the first number is 1, the remaining numbers are 2, 3, 4. So I can say, like, I can select 2, 3, 4. If the first number is 2, the second numbers could be 1, 3, 4 because 2 cannot be in the set. Similarly, for the first number is 3, the remaining numbers are 1, 2, 4. And lastly, if the first number is 4, the remaining numbers are 1, 2, 3. So altogether, we can select two numbers in 4, 1, 2, 3, 4, and the second numbers for every first number we can select it in three different ways. So 4 multiplied by 3 is 12 different ways, assuming the number order doesn't really matter. It could be 1, 2, 2, 1. We don't care about the ordering. Let's introduce you to a new symbol which is called factorial of a number. Say if you have a number n, factorial of n is like a L letter and the number n, or it also n exclamation, which means we multiply number n, n minus 1, n minus 2 all the way sequentially down to 1. So it's a sequential multiplication of numbers from 1 all the way up to n. Say in our example, factorial of n, or 4 exclamation, will be the multiplication of all the number 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 24. Or we can also break it down. Factorial of 4 is equal factorial of 4 multiplied by 3 multiplied by factorial of 2. So a new notation of permutations. So what is permutations? So permutation symbol is P, permutations, n meaning out of n objects, R meaning we want to select R objects. So NPR, or also written as NP sub R, which is equal to factorial of n divided by factorial of R. So in our case, you wanted to select 4 out of 4 objects, 2 objects. So the symbol will be P42. You want to select 2 objects out of 4, or 4P2, which is equal to, according to this formula, factorial of 4 divided by factorial of 4 minus 2. So factorial of 4 is 4 multiplied by 3 multiplied by factorial of 2, and the denominator is factorial 2, and we can cancel factorial 2 factorial 2. So the result is 12. So we could select two numbers out of 4 in 12 distinct ways. So that is the concept of permutation. So 4 P42 is equal 12. How about combinations? So if we go to the right side, combinations mean how many ways we can select certain numbers from a collection of objects, assuming the order really matters. So in here, last time when I computed permutations, we saw we could select two numbers out of four numbers in 12 different ways. But if you closely observe, here we have like 1 and 2, and in here we have 2 and 1. So if the order really matters, so we can only really consider them to be one way to select the numbers. Similarly, 3 and 1 and 1 and 3, they're the same. 1 and 4, 4 and 1, they're the same. So if you count all these different ways you can select these two numbers out of 12, we are actually left with 1, 2, 3, 4, 5, 6 different ways we can select two numbers. So the question is how many ways to choose two numbers assuming the order matters, which is the answer is 6, which can also be written as factorial 4 divided by factorial 2 divided by multiplied by factorial 2, which is like 6. So the notation is combinations C and R, meaning how many ways we can select R object out of a set of n is NCR or CR. So here the number of ways we could select two objects in permutation has to be divided by factorial R again. So that is the difference. So we can, the number of ways we can select will be lower by factor of factorial R. So in here, if you substitute C for 2 will be factorial of 4 by this formula, and in the denominator we will be left with factorial of 2 factorial of R, which is a new thing that we have to put in the denominator, multiplied by factorial of 4 minus 2, which is equal to factorial of 4 divided by factorial of 2 multiplied by factorial of 2. If you simplify, factorial 2 cancels out, and we are left with in 2 multiplied by 3 in the denominator, which is 6. So we can select two objects out of a set of 4 objects in 6 distinct ways, assuming the order of selection matters. If it doesn't matter, it will be 12 different ways. So here's the concept of permutation and combinations. Hope you find these lessons to be helpful. Thank you, and I'll see you in the next class.